Hello and welcome back to Cracking the Cryptic. And I've got a puzzle on the screen today. The more I look at it, the more gobsmacked I am that this is a genuine, unique solution Sudoku. If you know what blue lines are, you'll be able to deduce the rules. And it's just incredible that this can solve in a single way. We will look at that in a moment. I'm really looking forward to seeing how that works. It's by Nordy, who's often done some very tough puzzles on the channel. Actually, some medium, but some very tough on the channel. And we'll see which one this is. Going to look at that in a moment. I'm going to wish a very happy birthday to my sister for tomorrow, which is probably when she'll see this. Congratulations to you. I'm going to suggest that you look at our Patreon on the 1st of December when we'll be bringing you the Snack Doku 4x4 pack, a pack of 100 puzzles that won't individually take you very long. But obviously there's quite a few of them, and there's a solution to piece together from them all. I really think you're going to enjoy it. It's from the Skunk Works, of course, assembled by Panthera, one of the great friends of the channel, I'm delighted to say. And it is absolutely marvellous. When we first heard what the concept was, I will admit, we were thinking maybe this is a kind of mid-month thing. But having looked at the pack, it is so brilliant. This has to be our special December monthly reward, because we adore you patrons and you deserve these treats. So thank you very much for joining us on the channel. Now, there's also our Sudoku apps, great presents for Christmas, as is all of our merchandise range, especially the Christmas and holidays ones. Do have a look on the links under the video, or indeed on the links in the description field, or on the store tab, or wherever. And there's Sven's Sudoku Pad and all of that good stuff that goes with the channel. But if you click on the first link, you'll come to a way to play this puzzle in our software. And I'm going to go through the rules now and then give myself the treat of trying to solve this. So, normal Sudoku rules apply. We're going to put 1 to 9 in every row, every column, and every 3x3 box. Digits along each blue line have an equal sum n within each box the line passes through. Now, these lines, you will note, are not centered within the cells they pass through. And that's very deliberate so that we can see the different lines. So there is obviously a line going through those 4 cells, and those 2 must add up to the same as those 2. On this line, those 2 add up to the same as that one, which is the same total as those 2, and those 3. Equal sums lines rules. If you're familiar with those, you know what those lines mean. Digits joined by a white dot, there's only one of them, are consecutive. Digits joined by a black dot, there's only one of them, are in a ratio of 2 to 1. So one of these cells is half the other. And along the marked diagonal, which is obviously not blue this time, it's grey, digits cannot repeat. So that's a set of the digits 1 to 9. Fairly simple rules, no given digits. In fact, please, the more I look at this, the more incredible it is. Please notice, not only is this a lovely pattern, but the only disambiguator to stop this from being rotationally symmetric, which would mean there had to be 2 solutions, is the fact that the dot at the top is white and the dot at the bottom is black. Isn't that incredible? I mean, this, I haven't tried it yet, but to me this counts amongst the ranks of those brilliant puzzles which are more like discoveries than creations. And I know that that is never the case. The thing that looks most like a discovery is the best creation. So I'm just talking about how I feel about the setup. It's brilliant. Haven't started the puzzle. It's brilliant. And Nordy is brilliant. Give it a try. I'm going to start now. Let's get cracking. So we have very little to go on. There's not much point considering the dots, the diagonal line. So we're going to have to start with the equal sum lines. Now, these these 4 larger squares have a single cell and have a triple cell on them. And that means that the single cell has to be from 6, 7, 8 or 9 in each case. Because the 3 cells from the same box that add up to a number must be at least 6. Now, there's clearly going to be pressure. All of the digits in this sort of plus shape in the central box are going to have to be fairly low. They can't be higher than 6 because any set of 3 digits adding up to a single digit couldn't have a digit bigger than 6 because the other 2 digits would have to be 1 and 2. Okay, one way of looking at this, I don't know if it's the right way, but it's the way that occurs to me, is how many times we're going to count these cells. So let's make that one green and these ones orange. Yeah, this is good. This is good. Now, when we add up, so I'm going to consider all 4 big squares as a group together. Yeah. And when we add up, at the end of the puzzle, when we've completed the grid, when we add up the total of these 4 cells, let's make them yellow. When we add up the total of the 4 yellows, we're going to come to a number that can also be represented by, and I think it's 2 lots of all of the orange cells and 4 lots of the green. See if you understand why I think that. Do pause the video and have a think. Now, I think that because basically this yellow is going to be that orange plus green. This yellow is going to be that orange plus green. This is literally how the mechanics works. It's probably not as complicated as I'm thinking of it. That yellow is those 2 oranges and that green. That yellow is those 2 oranges and that green. Now, when we've added all of that up, we've added green 4 times and we've added each of these twice because they're each on 2 squares. Yeah, that's the simple way to look at it. So, what is the minimum value of all this green and orange stuff? If we were to put a 1 in the middle, we'd have to multiply that 4 times. And if we were to put 2, 3, 4 and 5, they all have to be different digits. They're all in the same box. On the oranges, 714 times 4 is 56 plus the 4 ones. Have I got that right? I can't have. No, sorry, I haven't. 2, 3, 4, 5 is 14, but we're only multiplying by 2, thank goodness, is 28, plus the 4 ones is 32. That is the minimum value of orange and green as it applies to the yellows. Now, what is the maximum value of the yellows? They can't all be the same. And remember this diagonal. These 2 could be the same. So they could be 9 and 9, and these could be 8 and 7. I reckon that gives the maximum value. And we were looking for 32, and that gives 33. There's 1 degree of freedom. That's marvellous. Oh, naughty. That is marvellous. I think that's right. Those 2 can be the same. Yeah, one way to look at these 4 digits. If you had another... let me just show you. If you had another line, another diagonal line coming down here, so they all had to be different. Then these 4 cells would all have to be different. They would all see each other. But without this line in place, I don't know what I'm doing. There we go. Got rid of it. Without that line in place, those have to be different from each other on their own line. But that one sees both of them. So those 3 have to all be different. Those 3 have to all be different. The only 2 of these that can be the same are those 2. And this amount of degrees of freedom where we said, well, we have to reach a total of 32 for the oranges and greens. So if all the yellows were different, we could only get to 30. 9 plus 8 plus 7 plus 6. So there definitely are repeats, and they must be in those 2 cells. So we can colour those red. They are the same digit as each other. In fact, Let's not do that. Let's leave them yellow and get rid of the yellow off these. So those two yellow cells are definitely the same. And they have to be, we only had 2 degrees of freedom from 9, 9, 8, no, 1 degree of freedom from 9, 9, 8 and 7. So they could be 8, 8, 9 and 7. That adds up to 1 less than 9, 9, 8 and 7. So these yellows are either 9 or 8. We now know that. And that well, can these even be a 6 here? 9, 6, 8, 8. No, 6, 8, 9, 9. 14, 23, 32. Yes, they can. Okay, I'm going to go back to green. I don't think green can even be 2. Because you would have 4 2s. And although you now might have 2 1s, that's a total 2 greater than if you had 2 2s and 4 1s. I mean, I'm not even doing the totaling in my head, but that must be right. 4, 6, 8 versus 8, 9, 10. Yes, we have to have a 1 in the centre. I was certain that's right, and now I'm 100% certain. These, indeed, actually, there's only 1 degree of freedom. So if you had not the minimum set of numbers now, if you had 2, 3, 4, 6, instead of 2, 3, 4, 5, that would add 2. So we can't have that. We must have the minima in the orange cells. So they are 2, 3, 4, 5. And now orange and green, as regards these cells, do add up to exactly 32. And we must come 1 degree of freedom away from the max on the outsides. So it's either a pair of 9s there, and then an 8 and a 6 here, or a pair of 8s there and a 9 and a 7 here. How do we decide about that? I think maybe we're going to have to think about this central plus again. Actually, yes, we're going to have to think about this central plus and how the individual trio sums relate to these cells. Yes, because we are either going to have, what is it? We're going to have either a 9 and a 7 here. I just said what this was. It's either a 9 and a 7 here, or a 9 and a 6. Now, I couldn't have said that. 2 9s is 18, plus 8 and 6. That's one possibility. But I don't know if that works. It doesn't work. It doesn't work. If you had 6 opposite 8, look what would happen. Oh, it's gorgeous. Look what would happen. Say this was a, I'll just show you. I'll paint it in. If that was a 6 and that was an 8, this 6 on its line would need 1, 2 and 3 to make 6. But that 8 would need either a 2 or a 3 on its line in box 5. It can't be 1, 4, 5 because that doesn't add up to the right sum. So that 8 and 6 is not what's going on the big line. And that's what would have happened if these were 9s. So these yellows are 8s. They're not maximal. And these now can't be 8 by Sudoku, and they have to be 9 and 7 to add up to the 32 that the plus shape makes. Isn't that brilliant? It's even a plus to show us that we're summing something up. I like that. Right, so this is a 9-7 pair. So. Ooh, I've just noticed that in this central box, with what we've eliminated, the corner cells are 6, 7, 8 and 9. And on the diagonal then, we can't have 7 and 9 again because of the diagonal rule. So 6 and 8 are placed sort of in the box, and then that becomes a 7-9 pair. Now, I don't think that does anything, but it's nonetheless interesting. This is absolutely wonderful, by the way. Oh, do I need to... How am I going to disambiguate now? These all look so similar. One of these is going to be a 7. So it's going to have 2 and 4 on it on the near orange cells. The other one is a 9 and will have 3 and 5. But one of these 8s will have 5 and 2 and the other will have 3 and 4. Okay, I'm going to hope that the white and black dots come into play now. I don't think they do, though. Do I have to think about these? It's surely not the small blue squares. I don't know. Where does 8 go in this column? Because it doesn't go there or there. No, actually, no, much better question. Where does 9 go in the column? Because 8 could be on either dot. But where does 9 go in the column? That's gorgeous. It doesn't go there or there. Not because it can't do by Sudoku, because it could, but because of the blue lines. We've got a 2-cell sum making 8. In each of these places around the Fistemafell ring, we've got a 2-cell sum making 8. None of those can include 9, so there's no 9 there. There can't be a 9 on a black dot because we're not allowed to put 4.5 in a cell. So 9 is up here on the white dot with 8. Now, here's another weird question. It's not quite the same thing. Where does 7 go in this central column? Because it doesn't go on the black dot. So actually, it must go in one of these cells. And it's going to be accompanied by a 1 as it moves towards its yellow 8, either there or there. And it's going to be accompanied by a 9 out here and a 2 next to the 9. Ah, this is so freaky. It's a bit like jelly to hold at the moment, this puzzle. Oh, I've just noticed on the diagonal we could fill in a 2, 3, 4, 5 quad. I don't think it does anything. I need to think more about this central, probably the central column. Because we've thought about where 7 goes, and it will go with a 1 and a 2 in its row. What about 6, which can't go in these cells? Does 6 go on one of these, or is this a 6-3 pair? Well, in fact, what is this black cell pair? It can't use 1 and it can't use 8 now, so it's either a 2-4 pair or a 3-6 pair. If it was a 2-4 pair, these two would be 3 and 5. And that doesn't work because of something I said earlier. I said that whichever the 9 is here is going to need a 3-5 pair, either sitting there or there. So the 3-5 pair can't be sitting vertically. I suppose another way of looking at that is one of these is a 7, and that's going to need an even digit in one of these cells. So we can't possibly take away both even digits and put them down here, 2 and 4. So this is not a 2-4 pair, and therefore it must be a 3-6 pair. Now we can take 3 out of those cells. Now, did that logic mean I knew what this... I know that 5-3 goes in one of these pairs and 2-4 in the other. I mean, it obviously means one of these is a 3. It also means the other one is not a 5. There's one even digit in those two and one in those two. Uh, 3, 6, 8, 9... I still don't see quite how to progress. Let me just keep thinking about this. There's no knight's move. Sorry, that's just a joke at my own expense. Am I meant to be using these now? I probably am. Yeah. Yes, look. Yes, I am. Right here. This pair adds up to 8 and doesn't use 3 or 6. So it's not 3, 5 or 6, 2. It's a 7, 1 pair and we can fill them in. 7 and 1. And now this is a 9. This is a 2 to make that 2, 7 pair add up to 9. Oh yes, here we go. So that's a 7 on the diagonal. That needs 1, 2, 4 in this inner ring. And these are now 3 and 5, and we know the order. That adds up to 9. 3, 6, 7, 1, 5. This is 2 or 4. Now, can we do more here? This can't be a 7-1 pair. Oh, we've got, oh, this can't be a 4 for that 8, of course. That's straightforward. 2 there, 6 there, 4 here, 2. Oh, I could have just done that adding up to 8. That would have been the simpler way. Anyway, here we are. We're right. That 6 is looking at the diagonal. This is a 5 to make that sum work. Now, what about this little number now, the little square? This one is 3, 4, or 7 by Sudoku. So this pair adds up to 8, 9, or 12, making this 1, 2, or 5. Oh, not very helpful. Oh, this blue square, this is big. Yes, all right. We're adding up to at least 10 there, so this has to be at least 8, and it's not 8, so it's 9. That's a 2 to make that work. We've finished off the central box. Gorgeous central box. I might as well decolor it now, and those 8s. Those can't be a 2 now. We've got 4, 5, and 8. I have to put 5 there. That's a 4, 8 pair. That's not a 4, so that's not a 2. This is a 3, 7 pair at the top of column 6. That's a 1, 4 pair. Now, this cell can't be 4 because of the 8 sum. So it's 5, 6, or 7. Let's start there, see what we can eliminate. This is 1, 2, or 3. This is 2, 3, or 4. Well, it can't be 2. I can see that. So that's not 7, and that's not 1. And that can't be 2 either. So that's a 3, that's a 5, that's a 4. Now, can we work the same little bit of magic this side? We don't have that given 2, so maybe we can't. This can't be 6, 4, or 3. So it's 1, 2, or 5. It has to be less than 7. Then by the 7, this has to be 6, 5, or 2, but it can't be 2 or 5. So that's a 6, that's a 1, that's a 2, and the whole central 5 by 5, all of the blue square stuff is done, especially if we finish off this, which we now can. Oh look, both of those little squares are repeat digits. Weird. Right, they can't have a 5. That's a 3. Can't get 3 in the corner. Can't get 5 in this corner. We've got 3 or 4 here. We've got 3, 4, and 9 to place. Oh no, that's 4 or 9. 3, 4, and 9 to place in column 7. In column 3, we've got 1, 6, and 7 to place. That can't be 7. I mean, is this puzzle still got something up its sleeve? It's been utterly brilliant that this disambiguates in this way. I've loved it, but... Ah, look at that quad that I've just created there. 3, 4, 5, and 6 are a quad, so that can't be 6. We've got 1, 7, and 8 to place in the box. I don't know. One of those is a 5, isn't it? In fact, there's only one place for 5 on this diagonal. Didn't spot that. That's clearly useful. That is it. So they don't have a 5 in. So these do. Or maybe it's not that useful. Yes, it is. I can place 5 in this box. There's only one. It's got 4 5s looking at it. So we get a 5 in the corner there. One of these is a 5 and one of these is 5. They're the last 2 5s in the grid. 5 didn't seem like it had any special significance in this puzzle, and it's the first digit to approach completion. Okay, I'm going to do some pencil marking because I've run out of other things. 1, 3, 4, and 9. So this is where 6 and 8 go in this box. Is that any use? Not really. I don't want to just pencil mark everything and see what's happened. It must be this diagonal. If we've got 2, 3, and 4 to place, 3 only has 2 positions. there and there. So those two cells can't be 3s. That doesn't look very helpful, not to me. It's probably just Sudoku. I need to concentrate on what I'm doing. Right. 3, 4, and 6. 1, 3, 4, 9. Finished all the blue. The diagonal I don't seem to be able to progress on at the moment. Ooh, this is strange. I didn't expect that. Okay, we will get pencil marking then. Those are from 5, 8, 9. Those included 2, 7, 8. Oh, look, that's a 2, 8, 7, 9 triple. Ah, I see. There's a 1, 6 pair that makes that a 1, 6 pair. That makes this a 3, 7 pair. Which doesn't do anything, does it? Yeah, it does. There's an X-wing on 3s. Oh, I see. I should have noticed 3 must be in one of those two cells. So it's not in these. I know about that 3, 4, 6 triple. Have I got anything going here? Not obviously. 4, 5, and 6. And one of them's a 5. Oh, sorry if I'm missing something now. This has been going so entertainingly. I don't want to suddenly stumble into a disaster at this point. Well, when I say entertaining, it's been entertaining me. I'm not pretending I know it's been entertaining you. Oh, one of those must be a 1 in that box. So these don't include 1. Still not getting anything done. It's weird. Why won't this give up? Ah, that is an X-wing on 3s, so we can't have 3 in the corner. How sad. But it's true. That's going to finish the diagonal, isn't it? That's lovely. Okay, that must be right. There is a 3 in one of those two cells, yes. So there's no 3 in the corner. 4 there, 2 in the other corner, 3 now on the diagonal there. That 3 looks down to here. What about the 4? The 4 looks along to there. That puts 3 here, 6 and 3. This is good. That's become a 9. That is a 3, 6 pair, so there's no 6 here. That's a 4, 5 pair. This is now a 2, 6 pair, which I can write in. There's a 7, 1 pair above it. That's 8, and that isn't. Yes, that 6 sorts out 6, 8 up there. Now, they can't have an 8 in. That's become a 4, so then I can write in 9 and 1. They can't have a 9 in. I've got a chocolate teapot quadruple there now. That can't be a 6. This must do it. Right, 9 and 8 are done here. No 9 there. That's a 3, 4 pair. So 9 in the box goes here. 8. That must be 7. I've got a 1, 2, 6 triple. No, hang on. I can finish column 3. That's a 1. That's a 6. Now, I must be able to use the extra digits here. So 4 there makes that 4, 3. And the 3 makes this 3, 6. That makes this 6, 1. That 1 makes this 1, 2. Now 2 goes here. 2 goes there. 8, 9, 7. Oh, just nip up and finish 4 and 1 before coming across to the teapot triple. There we go. 5, quadruple, 4, 5. That's a 9. What a brilliant idea. What a fantastic execution by Nordy. And it's not that hard. It's just utterly clever. How people have the conception that something like that might work is beyond me. And the placement of the dots to be different, I don't know. It's just genius. That's all I can call it. Just genius. Thank you for watching. Great fun today as always. Hope to see you again soon on the channel. Bye for now.